Please welcome maker and editor-in-chief at Tested.com, Adam Savage.
Morning. Welcome to day 2 of REMARS. Last night's speakers were truly outstanding. Today, first up, we have 3 speakers from Amazon itself. I've been learning about the core leadership principles at Amazon this week, and one of my all-time favorites, and specifically because it could have been one of our core operating principles on Mythbusters, is invent and simplify. Simplify is the one I always need to learn, because it's good to be clever, but not too clever. These next 3 speakers take invent and simplify to the next level. First up, we have Ty Brady, Chief Technologist, Amazon Robotics. As you can see, he has brought some of his henchmen, toys, to show. They've been working on, and I cannot wait to see your expression when he demonstrates them working. After Ty, we have Dilip Kumar, Vice President of Physical Retail Technology. Dilip is working hard on a future where I can run into a store, grab everything I need, and run back out, and somehow not be breaking the law. After that, we will hear from Rohit Prasad, Senior Vice President and Head of Alexa AI, who will share with us some of the amazing things Alexa has been up to. Let's just say she's growing up so fast you might not even recognize her. So let's get to it. It is my pleasure, first up, to introduce my friend Ty Brady, Chief Technologist, Amazon Robotics. Let's give him a hand.
All right. Hello, hello, hello. Welcome to REMARS. So awesome to be here. Great in person, live in Las Vegas. Could be some late nights out there, so thanks for showing up this morning. Also, big thank you to the online crowd out there. Thank you for joining us. My name is Ty Brady. I'm the Chief Technologist at Amazon Robotics. And this year we're celebrating 10 years of serious investment of robotics inside of Amazon. In that period, we've created more than 1 million new jobs, have completely transformed e-commerce, and have delivered and deployed more than 520,000 robotic drive units in the field. So today, what I'd like to do is I'd like to share how we think about robotics, kind of our bot philosophy, and some new products that create an even better employee and customer experience. But before we do that, I'd actually like to share a personal story. So this is my grandfather. He lived to be 97 years old. He's a self-made man, and at the age of 12, became a lumberjack in the woods of northern Mississippi. My great-grandfather, his father passed away at an early age, so he became head of the household and had to care for his brothers and sisters. He lived a really good life and was a really wise man. So a few years ago, I was able to sit with him and reflect about a lot of things, including technology. And if you do get the opportunity to sit with the prior generation, the elderly, your loved ones, do so. It's really incredible just to hear the stories. So I asked him, I said, what are the 3 most impactful technologies that you've witnessed in your lifetime? He thought about it and he said, the tractor, the icebox, and the airplane. So the tractor I get, he had to, he can plow a larger field, he can grow more food for the family. Got that. In the icebox, of course, you can keep food overnight, which is a big deal. Especially in the era of the Great Depression, for sure, huge deal. But the airplane was different because he rarely flew. His entire lifetime, he rarely flew. So I pressed him on that. And he said, when he was 14, this is like 1932, 1933, he was 14, he saw in the local newspaper that a barnstormer was coming to town, an airplane. So he and his buddies kind of went down to the local field. And I don't mean airfield, I mean literally the field. Went to the field and saw this airplane rumble down the field and just magically take off. He literally thought it was a miracle. He could not believe his eyes. It's in complete amazement. And he said that at that moment, he knew the vast potential of flight. He didn't know how it would manifest itself, but he knew it was going to be awesome. And he was right, because a new golden era of aviation was born. And I share this because today we are witnessing a new golden era all around us in robotics. We see the vast potential in robotics, and we're excited to shape not only what is in robotics, but what can be in robotics. So first, a bit of our own mental model, how we think about robotics. So at Amazon Robotics, we provide solutions to automate the fulfillment process. We can break everything we do down into these 6 core operational verbs. They're manipulate, move, store, sort, pack, and identify. And when we achieve a world-class capability in each of these core capabilities, we unlock a vast potential of productivity and safety to get the right good to the door. So, each alone will rarely accomplish the task. Each of those core verbs alone just won't do it. So we need to integrate these into purposeful work cells for the solution to be performant. And I say purposeful because we do not do technology for technology's sake. We first ask, what problem are we trying to solve? And then how can we smartly add automation that enhances the safety and the productivity of our employees? When we do this, we don't just put the pieces together as well. Instead, we need to design our machines to be integrated work cells capable of quickly integrating into a larger system of systems and avoid what we call islands of automation. But we're not done. Because the real mental model is for our products to be magically simple. Complex is easy. Simple is hard. We build our machines such that humans are at the center of the robotics universe, something that is intuitive and doesn't make you question your own mental capacity on how to use it. It should feel like it's made for you. The machine should be easy to support, given the large installed database. The machines should be robust, reliable, and most importantly, safe. Should let the user know the stats at any time so you can understand what the machine, what the intent of the machine and how you can task the machine. And at the highest level, the very highest level, we aim to extend human capability and build collaboration between people and machines. Extend the human reach. We have an exceptional team of scientists and engineers from around the globe who work on this every day, and they have done a phenomenal job of advancing the state of the art of robotics. I also want to just give a shout out to the rest of our team. We are one team. Our financial team, our human resources team, our manufacturing team, our legal team, our support team, our deployment team. We have an amazing team that work very hard to do needle-moving activities every day, and I'm thankful for the entirety of our one team. So, rather than talk about this mental model, let's spend a few minutes sharing what we've been up to. First is storage. So if you want to be able to sell basically everything, you need to be able to store basically everything, and this is hard. So if you look behind me, you'll see those yellow pods. How we do it today, it's a goods-to-person system. That means instead of a person going to the goods in order to fulfill an order, the goods will actually come to the person to fulfill the order. This is revolutionary. Today, the goods go directly into those yellow pods, and then we have our drive units, the little orange units you see down below. They move those pods of goods on demand whenever and wherever we need. So when there's an order to be placed, we'll get the right good at the right time through the magic of our system here. But we asked ourselves, we took a good look at this, how can we simplify this, and how can we make the job easier and safer for our employees? So the first thing that we can do is containerize everything. And if you are an AWS geek out there, I do not mean Docker's containers, okay? These are physical containers. I know we're at Remars, got to get this straight. But containers give us known interfaces, and they help us automate, right? So we can count on those interfaces, so we can move things, we can manipulate things. Those core verbs that I said before, we can now build to those interfaces. The known interfaces help us automate. We can store goods into the containers, and those containers can be actually now stored into the pods and leverage the work that we've done prior, the 10 years prior. That allows us to carry more goods within the storage field. We want to be able to move these containers and pods whenever and wherever we want, whenever we need them inside the building. And we also, because it's a container, we want to put them just at the right height. We call it the Goldilocks zone, so that you don't have to get down and try to pick something here or stow something up top. We don't even want to use ladders. We want to just keep the ergonomic zone perfect for our employees. And also, even when it's in the container itself, we have smaller batches. There's fewer goods inside the containers, which allows for better quality. that we can do automated item counts on top of it, and we can quickly see if there's any damage inside the container as well. So that's how we wanted to simplify it. But to do it, it's hard, right? This is not an experiment. These are real products that are going into the field at a massive scale. So we had to invent quite a few things in order to make this happen, and you really have to pay attention to the details. For example, a larger pod is heavier, has different dynamics. It sways, so we had to modify our drives in order to deal with the dynamics of this larger pod. We designed new end-of-arm tools to easily shuffle the totes from the pods into the various carriers that we have to move those containers throughout the building. And we also even identified a new multimodal identification system so that if we have something in grasp, we can better identify those objects before it goes into the container. So I can give you more words, but I did bring home a couple home videos, so I'm going to share with you some of the videos and see it in action. So now we have the goods stored, and we need to be able to get those goods into our various packages and complete that order. And it is a symphony of people and machines working together to do this. We index highly on safety in order to do that job, but you can't do one without the other. We could not have achieved what we've done throughout the pandemic without having the right blend of automation and our amazing employees frontline. So once we have the goods, we package them up for the customer order, and we want to further simplify how we sort and move those packages throughout our building. We want to be able to load them onto the trucks, a process that we call outbound dock. So you get the packages, and then you need to go to the right truck in the right dock. So how can we simplify this? Well, first, we don't want to move single packages. We want to move batches of packages at a time. And we put them into things called carts. You can actually see one up on stage here, or a go-kart, to move them around the building. So we can batch our packages together for easier movement. We want to automate the placing of those packages inside that cart. We want to do that with some robotic arms. And we'd like to automate even the movement of the carts from the building, whether it's the inbound dock door all the way to the outbound dock door. This helps create a better overall flow and creates a better work environment for our employees by reducing the repetitive tasking and the operation of heavy machinery around people. So to do this, again, invention is required, but our amazing staff. I'm super proud to work with them every day. They invented a novel safety system for the movement of these drives to seamlessly and safely move around people. They designed new algorithms to maximize how many packages that we can put inside that container. It's like the ultimate game of Tetris. They optimally designed new end-of-arm tools to reach into hard places, to place packages into containers like this, but also on conveyor belts and other places that we need in order to move the packages through the building. This all results in this symphony of people and machines working together. Even more, like we think now you're thinking at the building level, right? The building level. So we had to invent new software, think of it almost like a building operating system to integrate all these pieces together. Again, a symphony of people and machines working together, doing some really needle-moving things. So again, let me show you this in action. Awesome. So I have a treat for all of you, you crazy cats out there. We have one of our autonomous robots that we call Proteus here live on stage carrying one of our go-karts. It's meant to work in the unstructured environment, is capable of going from point A to point B, of course. It's our 5th generation drive. It leverages 10 years of experience of building various hardware systems and software systems in order to make this drive move intelligently throughout the building. But I gotta tell you, the really cool part is that it's human aware. It understands where I am or a group of people around me and will methodically make its way to the destination. It doesn't just stop. It'll slowly make its way in a very safe manner around people and get to where it needs to go. Really incredible work. It does this by fusing together a huge array of sensors into an independent hardware system inside the Proteus drive. That maintains a safety bubble around the drive, so it's constantly aware of obstacles in its way, and most importantly, people. So it can replan its path constantly. Amazing work by our team. Super proud of what they've done in a short amount of time. Really great. So let's talk about something as simple as identifying an object. And that object can be something that you buy on Amazon.com, or it can be a package. It seems easy, right? That's super easy, but it's not. You might have to manipulate a scanner. There might be shiny surfaces all over that object. You might not know where the barcode is. The text is not legible, right? We're really good at understanding that, and we wanted to simplify how we do this. How? Well, first of all, we like to be able to use both hands. It's much more natural, right? We don't have to carry a scanner. Use both hands. It's actually even safer as well. If you had a heavy object, you want to be able to use both hands, not one hand. We didn't want folks to search for identifiers. We wanted our systems to automatically do that. And also, if we have the object right in front of us, let's do a quality check. Is the object damaged? We have it right in front of us. Let's take a good look. So, again, complex is hard. Simple. Complex is easy. Let's get that right. Complex is really easy. We can just jam a whole bunch of things together. Simple is what's hard. We leverage years and years of machine learning and computer vision expertise to help disambiguate these complex environments at high speed. We invented new methods to scan a large volume at high resolution and high speed. We wanted to make identification more natural within the human environment. So instead of a video, how about I show you all a live demo? This is Abby. Abby's a technical program manager with us at Amazon Robotics. Thanks for joining us on stage. Abby, you want to say hi to a couple thousand friends that we have out here? Thank you. So you can see she picks up a package and she places it into the container. We work hard to make it so simple. So simply just pick it up. She goes through the arch there, and every time, now the green lights aren't what we actually have in the fulfillment building, but we put it here so we know you have a positive scan. Go ahead, yeah, put a few through. And what I really like is the process works with her, right? It adapts, it's very natural. We want our solution to adapt to her actions. She's not even thinking about identification. Identification should just happen, naturally, ubiquitously, it should happen. Also, the cool part is just how fast it is. You ready for this part? I'm ready. All right, so let's make sure it's not scanning. Go ahead, just do a single scan. Okay, check. Let's see how fast you can get it going. Can you go even faster? Even faster? That's awesome. You want to throw it through? I know, I had to. There you go, it worked. All right, awesome. Thanks, guys. Thank you, Abby. That's awesome. Thank you. That's great work. Just amazing work. Amazing work. You want it. We work hard to make it so simple. Thank you, Abby. That's awesome. So we are in the early days of robotics. If it was aviation, it'd be the 1930s. If it was computers, it'd be the 1950s. You know, the giant computer in the room that does the one teletext on the bottom. The very early days. Innovation's in our DNA at Amazon, and we are in it for the long haul. We are a patient group, and we will always innovate on behalf of our customers. We also realize that not everything has to be invented internally. So this year, we started a new industrial innovation fund where we're investing $1 billion to help see some amazing companies doing some great things here in the early days of robotics, the barnstorming days. So this is Digit from Agility Robotics. Agility's help us understand what's possible in bipedal robotics. Did you want to wave hello or something? It's cool. Love it. Awesome. It's really exciting space to be in. We really look forward to the possibilities of bipedal motion and understanding what's possible with bipedal robotics. Really happy to have partnered and make the investment into Agility Robotics, doing a great job, really pushing the needle forward in terms of robotics. Exciting space to be in. We've already invested in several other companies. Your company may be one of them as well. We're really looking forward to anyone who has a great idea around machine learning, AI, automation, and robotics. We'd love to talk to you, and we'll continue to accelerate our industry using this fund. So, I do want to end with this quote from Roy Amara. He says, "We tend to overestimate the effect of technology in the short run and underestimate the effect in the long run." And I can really relate to this. I remember in the early days, remember the flip phone? Early days. Got that, like, okay, sure, I want to call my buddies. But I also wanted to text. I wanted to take photos. I was really excited about making games on the phone, but the screen was like this tiny little screen. If you're texting somebody, you're like 33812, like it was terrible. The hardware wasn't really ready. But even then, I couldn't even imagine that we would all basically have a supercomputer in our pocket today. And we could do all that and a lot more. And this relates to robotics as well. So you may be on one end of the spectrum. In robotics, you may be like, dang, that's super cool. Now, where's my Rosie the robot? Where's my flying car, right? Or maybe you're way over here. You're like, robotics, psh, well, that's done for me lately. If you have that opinion, you probably don't value your dishwasher too much. But, okay. I like to think that I'm right in the center. But the reality is, like my grandfather with the airplane, I too know it's going to be awesome, given the amazement, the wonder, and the vast potential that robotics has. The promise of robotics is bold and will help shape the future of technology, not only for fulfillment, but for the betterment of society. So come join us, reimagine the future together. Thank you, Remars. Stay awesome. Thank you.
Please welcome the Vice President of Physical Retail and Technology at Amazon, Dilip Kumar.
Good morning. Glad you could all be here. My name is Dilip Kumar, and I'm excited to talk to you how Amazon uses machine learning to invent customer experiences in physical spaces. Earliest estimates, so the first time someone exchanged currency for goods, dates back to about 2,800 years ago in ancient Greece. When something hasn't fundamentally changed for such a long time, it can be a daunting task to try to reinvent it, but also fun. And this is exactly where machine learning comes into play. With an equal dose of creativity and machine learning, you can create magical customer experiences that your customers will love. 3 years ago, when I was here on the same stage, we had just started launching our Amazon Go stores with our Just Walk Out technology. A lot has happened since then, including a little something known as the pandemic. Let me tell you what we've been up to. As many of you know, we opened our first Amazon Go store in Jan 2018, and in less than 4 years, we've drastically increased the capabilities of the technology. And we went from 1,800 square foot stores to full-size grocery stores that are run using Just Walk Out. We now have more than 50 stores across the Amazon Fresh and Amazon Go banner in the US and UK. And we now have more than a dozen third-party locations as well, a growing segment for us that have this technology. In summer of 2020, we launched the Amazon Dash Cart, a smart cart that allows customers to be able to add items to the cart, have a running tally of their total, and skip the checkout line when they're done shopping. In fall 2020, we launched Amazon One, a fast, convenient, contactless way that allows customers to enter, identify, and pay using just the power of their palm. And last but not the least, last month, we opened Amazon Style, our first ever physical apparel store that brings together the power of machine learning and operation to create a personalized shopping experience that customers love. But where did this all begin? How did we get started here? Well, several years ago, a group of us got together to try to see what we could do to reinvent physical retail. Now, physical retail, as you all know, there's a lot of choices for customers. It's very well served. And the last thing we wanted to do was to come up with another Me Too offering. Several years and many iterations later, the things that we kept coming back to is that customers didn't like waiting in lines. So after many iterations, what we came up with was Amazon Go, which launched with the power of Just Walk Out technology that uses computer vision and machine learning algorithms to keep track of all the activities that customers have in the stores. And every time you take something from a shelf, an item gets added to your virtual cart. Every time you put something back, it gets removed, so that when you're done shopping, you could just walk out. No stopping or waiting in line to pay. That was the power of what machine learning can do to create magical experiences for customers. In the last 4 years, we have drastically increased the complexity of what this technology can do. On the one hand, we went from 1,800 square foot convenience-sized stores to 40,000 square foot grocery stores. On the other hand, we also increased the diversity of environments that this technology is in. We went from street front retail to having locations with third-party customers in airports, stadiums, convention centers, and many more. Now, as you can imagine, this came with a set of challenges. When you go from an 1,800 square foot store to a 40,000 square foot store, the obvious thing is that there is an explosion in the number of products. But it's not just the number of products. It's what the interactions that those products enable and make complex for the computer vision algorithms to do. Let me give you a couple examples. Picking up a can of Coke is a relatively straightforward interaction that the algorithms can handle. But when you're shopping for apples, it's actually a lot more considered purchase. All of you are rummaging, you're picking different things, you're sort of generating a whole bunch of events. You're trying to get the 6 perfect apples. And while that seems extremely natural for all of us, it's incredibly difficult for the computer vision algorithms to be able to accurately keep track of all the takes and returns to be able to charge accurate receipts. Very similar when you sort of scan to make sure that you're getting the last jug of milk that has the latest expiration date. Again, a very natural behavior, but something that increases the complexity for the algorithms. In a grocery store at peak, there is a significant number of customers who are shopping concurrently compared to what you would see in a convenience store, and the shopping trips are also much longer. That poses challenges not just for the algorithms, but also for the infrastructure to be able to orchestrate these sessions to be able to generate accurate receipts. In a grocery store, there's a plethora of fixtures. You have everything from hot food, cold food, self-serve bars. You have associates behind the counter who are serving meat and seafood. Even in our stores, we have hybrid checkout where you can check out either using the point of sale or you could check out using the Just Walk Out. All of this drastically increases the complexity of what the algorithms need to deal with in order to be able to generate accurate receipts. Expanding JW to third-party retailers also came with a whole host of challenges. These stores are in locations that could be open almost 24/7 in an airport, or in a stadium where you can imagine the typical customer behavior is that during intervals or periods, there is a whole mass of customers that descend on the store in a very short period of time. Or we had to be able to change our technology in order to make sure that we fit into the retailer's operations. So we couldn't have any sensors on the floor. All the sensing needed to happen in the ceiling. Each and every one of these interesting challenges was something that the team had to solve in order to be able to generate accurate receipts for customers. There's one problem that I want to talk to you about. We talk about, it's about vibration. All buildings have them, so does this. And generally, they're very benign. But why is this relevant? When you're in an environment where you have a rock concert going on, or there is in an airport, vibrations can actually take on a lot more than the normal and have a really pernicious effect on your accuracy. Why? Because when your sensors are vibrating, being able to sort of detect picks and returns that a customer is doing at that same time can be really difficult. So in addition to building computer vision algorithms, we also had to build several sophisticated digital signal processing algorithms that was able to filter out the signal and create just to know when the picks and returns are happening and eliminate all the noise. This is a pretty challenging problem because you don't know when these situations might exactly happen, and you have to react very quickly to it. Our cameras had very similar problems as well. When you think about grocery stores, you think about very high ceilings, and those cameras need to be brought down in order to be able to view the products. You think about airport stores, they may actually have very low ceilings. And in all those instances, you need to be able to protect against vibration because any of that can cause parallax effects. Our cameras in the first generation used to stream all the data to the cloud. Since then, we made the cameras a lot smaller, a lot more compact, a lot more powerful, so that we had the ability to be able to run all our algorithms either locally in the store, so we could actually bring the compute to where the data was, rather than sending everything to the cloud. Or in cases where there was bandwidth constraints, you could run a lot of that locally using edge processing or on the cameras. And then when the bandwidth restrictions were lifted, you could send a lot of this information back to the cloud. So we had the ability to be able to mix and match depending on the environment. While these were very interesting challenges, the thing that I contend, and I said this 3 years ago, is that the hardest problem we still had to solve was that we had to make this technology entirely recede into the background, so that when you, the customer, came into shop, the only thing that you cared about was being immersed in the shopping trip. We took care of all the complexity behind the scenes so that you have a stellar customer experience. And I'm glad we lived up to that North Star vision of what Just a Walkout promises. Amazon One. In 2019, as we were launching our Amazon Go stores, one of the things we noticed was that there were still many instances where people were fumbling around to identify themselves. They were either fumbling with their credit cards or wallets or phones to be able to either identify themselves or pay. And we thought that there had to be a better way to do this. Now, because this was a physical environment, it had to be very simple, it had to be intuitive, and it had to be something that customers always have on themselves. Enter biometrics. Now, the reason that we sort of picked biometrics is that there's plenty of choices available. You could have chosen fingerprint, you could have chosen face, you could have chosen voice. There's a variety of choices available for us to choose. We selected Palm for a variety of reasons. The first was that we wanted this to be private. What do I mean by private? By that, what I mean is that just looking at an image of your palm does not give you any clues as to the physical identity of the individual, unlike face or voice, which can be highly descriptive. Second, we wanted this to be contactless. Now, while this was pre-COVID, we still felt that because this was going to be a public device, we didn't want any touches on the device. So unlike fingerprint, we wanted the biometric that we chose to be contactless. Third, we wanted this to be very intuitive. As I said, this is a public space, and you wanted to make sure that it required very little training. And we wanted the customer to take a very intentional gesture of holding their palm over this device in order to get identified. So the gesture had to be very intuitive, but we also wanted the customer to always be in control of when and where they choose to get identified. And last but not the least, what's the point of a biometric if it's not accurate? So we wanted to make sure that any biometric that we choose, in addition to sort of being very descriptive, is highly accurate. So in addition to choosing palm, we also went to get the subsurface images of the vein information. So the combination of palm and vein made it an order of magnitude more accurate than what face recognition can do. Once we figured out what we needed to do for the biometric, we started assembling the software, hardware, and the product teams in order to be able to build this product. Now, from a hardware perspective, because we chose palm and vein, we had to build pretty sophisticated optics to be able to get the right level of detail at the right frequencies to be able to get palm and vein data that we could fuse them together. From a software perspective, as I said, one of our design principles was we wanted this to be very intuitive for customers, which meant that as a customer comes in and hovers their palm over the device, we wanted to provide guidance to them in real time to know exactly where to hold their palm so that they can be very quickly identified. Our latency targets for this was like being able to be identified in less than a second. So this had to be a very quick turnaround process. Secondly, we wanted to be able to also make sure that you can associate a credit card to your palm. So as long as you can do this in a very quick manner to be able to register, that was one of our design goals. I'll talk about some of the research challenges that we had as we had to do this shortly. As with everything that we do at Amazon, we also always take security as a number one thing that we also consider. Now, in addition to that, because this was biometrics, we went many steps further to be able to figure out that, like, how do you sort of make sure that the device is tamper-proof? How do you make sure that there is no information that is stored locally on the device so that if the device were to get lost or stolen, nothing gets lost? And then we had to securely transmit all these images to the cloud and store it in a secure zone. All of these controls were put in place for this device because we needed that for any public device to be sort of a biometric device. One of the things that we also did, and early on teams used to ask us this question, is that, well, what if someone took a high-powered image off your palm and hovered it over the device? Well, we tried to handle that, and the way we did that is using something known as liveness detection, where we could figure out, in addition to the palm, also the vein data and blood flow within the veins in order to be able to distinguish between live hands and fake hands, to be able to boost the accuracy for this device. Now, one of the things that I said about the research, there's plenty of reasons that we chose Palm, and those were all highly positive. One of the downsides of choosing Palm was that, unlike face or voice, there's not a whole lot of data available in order to train your algorithms. There's not many publicly available data sets. So what we had to do was that we had to rely on synthetic data to be able to create synthetic identities of the palm. Now, unlike face, this is not really a solved problem. And so we needed to make sure that these images are photorealistic, because adding just synthetic data that does not reflect the reality of the palms that you would see in the real world would just add a lot more noise and not be able to train our algorithms well. We were able to generate tens of millions of synthetic data in order to be able to get the accuracy to where we needed to, and to be several orders of magnitude more accurate than what face recognition can do. In our stores, we have plenty of ways for customers to enter. They can use a QR code to enter, they can use a credit card, or they can use the Palm. They can use Amazon One. One of the things that we've noticed is that when people start using Amazon One, they seldom switch back to using any of the other methods. It just proves that it's a very easy, very intuitive, and a very straightforward way for customers, and it provides the convenience, and I'm glad that we were able to deliver on that promise. The dash cards. So I said that we launched the dash cards in summer of 2020 to be able to offer customers another convenient way to skip the checkout line. The way the customer experience works is that you take a QR code on your Amazon app, you get a cart. Once you start adding items to the cart, there's an array of cameras on the cart, as well as the weighted basket, which identifies the item, identifies the count of the items being added, and gives you a running tally so that when you're done shopping, you can just skip the checkout line and leave. Customers have loved this, and they feel that the experience is very simple and intuitive for them to use. But this also had some very interesting design challenges for us to handle. The first one was we had to be able to add a screen. We had to be able to add weight sensors to the basket, which had to be NIST certified. And we had to add an array of cameras and illumination in order to be able to identify the products accurately. Now, doing all of that adds weight to the cart. So we had to very carefully decide what elements of the cart were going to remain, what elements of the cart can we remove, so that we can actually make this ergonomically useful for easy maneuverability in the store. And I think that was one of the design challenges that we had, and the team was able to deliver on that. The second thing that we did is that when our early prototypes were being created, we had 20, 25 cameras strapped to this cart to be able to identify all our algorithms, and then the algorithms were not really very optimized. So what it did was that it was generating so much heat that it would have probably melted anything that you put in the cart. So the engineers did something clever. They attached a giant fan to the cart, which blew air over it so that you could keep the processors from dropping. So that's success. And so we were able to run our algorithms for a little longer. But an unintentional side effect was that the cart started moving by itself. So we may have unintentionally created the world's first self-driving cart. But as you can see from the earlier pictures, we were able to solve these problems. Watch this. Now, that sounds like fun, and it probably was. But there was a method to this madness. Customers shop very differently. Sometimes they shop directly into the basket. Sometimes they hold it to the cameras. So we had to be able to figure out how to be able to build this, figure out what the right camera positions are, figure out the right illumination in order to be able to get the right accuracy for what these things needed to do. And there is a surprising amount of complexity that goes in building a dash card or a smart card that can be very intuitive and easy for customers to understand. Again, very similar to Just Walk Out, one of the things that I'm super proud of is that we hid all of that complexity from customers so that when you, the shopper, came into the store, all you could be immersed in your actual shopping trip, in your mission, and not be perturbed by anything else that was going behind the scene, and we handled all that complexity. Amazon Style. Last month in LA, we launched our first ever physical apparel store that brings together the power of machine learning and operations to offer a very personalized shopping experience for customers. Now, the way the customer experience works is that when you get to the store using your Amazon app, you can fill out an optional survey that tells us about your likes and dislikes and anything that you may be interested in. Or you could just start scanning items on the shop floor. We send those items to a fitting room, or if you knew exactly what you wanted, you can send that directly to a pickup desk, and you can be on your way. But if you wanted to send it to a fitting room, we send all the items that you have scanned to the fitting room, but this is where the fun begins. In addition to sending the items that you have scanned or using the information that you may have entered about your likes and dislikes in the optional style survey, we also created machine learning picks that sends information about things that might be highly relevant based on the items that you have selected, or things that might be complementary, or just things that might be serendipitous and just plain fun, things that you may not have necessarily wanted to pick or even thought that you would try, but we sent it. And one of the things that customers love is that they have loved the idea of being able to get other picks in addition to the ones that they have selected, and they've really taken to that. The fun doesn't have to end when you're in the fitting room. When you're in the fitting room, you can actually keep asking for more items to be sent to you. And every time you're interacting with the screen, every time that you're asking for more items to be sent to you, you are constantly getting feedback. And the machine learning algorithms are updating in real time to be able to give you new additional picks. So the more you shop the store, the better those picks get, the better those recommendations get. There's a saying at Amazon that it's still day one. And it's definitely day one for all of these technologies. Be it Just Walk Out, be it the Dash Cart, be it the Amazon One or Amazon Style, we're very early in our exploration of pushing the boundaries of machine learning to create these experiences for customers. There's a whole lot of innovation ahead of us, and I can't wait to be able to share those with you in the coming weeks and years. Thank you for your time today.
Please welcome the Senior Vice President and Head Scientist of Alexa AI at Amazon, Rohit Prasad.
Hello, thank you for coming. It's great to be here with you again after 2019. At Amazon, our vision is to make AI useful for customers in their daily lives through what we call ambient intelligence. By ambient intelligence, we mean that the underlying AI service is available everywhere around you, assists you when you need it, even anticipates your needs, but fades into the background when you don't need it. The best glimpse of that future of our AI service, Alexa, is making today in our customers' lives as their personal assistant, advisor, and companion. Alexa gets over 1 billion requests per week from hundreds of millions of devices available in more than 70 countries and 17 languages. Alexa is available in our homes, cars, phones, and now Alexa is also headed to the moon as part of the Project Artemis. Alexa customers have access to more than 100,000 skills. I think of this as that there's a skill for every moment of our customers' lives. While majority of the actions that Alexa takes today are initiated by customers, we are seeing a massive growth in proactive actions, by which we mean actions that Alexa initiates on customers' behalf. The best examples are things like hunches and routines, where Alexa turns on your coffee machine at a particular time or lets you know that your garage door is open. Today, more than 30% of actions in smart home interactions are all initiated by Alexa. This massive collection of reactive and proactive assistance is brought together by a large number of machine learning systems working together to process different sensory signals, such as speech, visuals, ultrasound, touch, and of course, all the contexts are available to Alexa. In fact, this orchestration of more than 30 sophisticated machine learning systems within Alexa makes it one of the most complex AI applications in the world. While the depth and breadth of machine learning powered by pervasive state-of-the-art deep learning in Alexa is unprecedented, our customers expect a lot more. We believe the only way to meet customers' demand is through generalizable or general intelligence, not to be confused with the all-knowing, all-capable, uber artificial general intelligence, or what is colloquially known as AGI. Instead, by generalizable intelligence, we mean the AI has 3 key attributes. First, the AI generalizes its learning across many different tasks, just like we as humans do. Second, it continually adapts to the user's environment. Third, it even learns new concepts through self-supervision or at least minimal external input, just again like we as humans do. In our quest for ambient and generalizable intelligence, we are ultimately aspiring to combine the best of human intelligence with the best of machine-like attributes. While we as humans are also very specialized, I hope you agree, we set a very high bar for generalization. While AI is still very far from achieving such human-level generalization, the field of deep learning, and more recently the use of large transformer-based models, has revolutionized AI services to generalize far better than ever before. These large networks trained with self-supervision on massive corpora are being used in a variety of areas, from generating code from natural language to images to even natural responses in human-machine interactions. At Amazon, we are advancing such transformer-based models in 3 foundational areas: multitask intelligence, multilingual intelligence, and multimodal intelligence. The most obvious multitask intelligence scenario is where different tasks in the same modality are learned more efficiently. For example, through large-scale acoustic neural encoders, we are efficiently representing the underlying structure of speech across many different tasks of, say, acoustic event detection or wake word detection when you speak the wake word Alexa, or speech recognition, which is the process of converting speech to text, or recognizing the speaker recognition. Modeling them all jointly with as much sharing improves both training and inference efficiency. We're applying similar multitask learning to visual modality on Alexa-enabled devices with cameras. For example, to determine if the customer is addressing the device or someone else in the room, here typically independent tasks of head detection and pose detections are all learned through shared visual encoder layers. Most transformer-based large models in the scientific literature and real-world use cases are typically trained on a single language. with billions of parameters trained on large corpora. Here again, we are taking a very customer-obsessed approach where it's not just the size of the general language models measured by the number of parameters, but its competency in multiple languages versus a single language. Let's take an example of how Alexa is trained to interpret customer requests in multiple languages. First, we train a generic language model on publicly available corpora in 12 languages. This generic language model uses encoder architecture, again using billions of parameters, using self-supervised learning on unlabeled data. Next, we use the Alexa data to adapt this model to the Alexa domains. This model we refer to the Alexa teacher model because it can be applied to many different AI tasks within the complex system of Alexa. Using novel techniques then, we distill the Alexa teacher model to a tractable size and also adapt to the specific tasks and languages needed by our customers. This approach is already deployed in French, Italian, and Hindi since 2021, yielding substantial accuracy improvements, at the same time reducing our data requirements. We aren't stopping with multilingual models with large transformer models and have extended the Alexa teacher model to multimodal language models. For example, multimodal language models are enabling visual scene understanding such that you can say, is the window next to the sliding door open? The natural question to ask is, what do the advances in these foundational models as part of generalizable intelligence mean for our end customers? One obvious result is more natural human-like conversations. In 2019, on this same stage, we introduced Alexa Conversations, which is being used by developers to build experiences on Alexa that enable free-form interactions through deep learning instead of the developer writing a lot of code to enumerate all possible ways an interaction can progress. Earlier this year, we took Alexa Conversations to a new level by launching what we call Conversation Mode on Echo Show 10, which is a device that has a motor which makes the camera and the screen move with you. Conversation Mode eliminates the need for speaking the wake word on every turn. To do so, audio and visual input is processed locally on the device and combined to determine whether a customer is addressing the Alexa or someone else in the room, so that you don't have to say the wake word at every turn. Next, the text generated through on-device speech recognition is processed in the cloud to generate the best response on each dialogue turn, again making the conversation much more natural than before. Today, I'm delighted to share a new capability on ambient devices such that you don't have to pull out the phone or go to your laptop or a desktop to explore a topic of interest on the web. Let's take a look.
Alexa, what's the oldest living tree?
The oldest known living tree in the world is a Great Basin bristlecone pine located in the White Mountains in California. It's 4,853 years old. And here's more to explore.
What are some other facts about it?
One of the reasons Great Basin bristlecones live so long is because their pine needles can survive for up to 30 years. That lets them conserve energy and grow slowly.
Where do they grow?
They typically grow in harsh alpine areas above 10,000 feet in the western United States. This includes places like Great Basin National Park and the White Mountains.
Tell me more about the White Mountains.
The White Mountains of California and Nevada are a triangular fault block mountain range facing the Sierra Nevada across the upper Owens Valley. They lie within the eastern section of the Inyo
Are there
National.
any good hikes?
My recommendation is the White Mountain Peak Trail. It's a great day hike. And here are some other nearby hikes, and a guidebook about the area.
As you saw, Alexa guides you as an expert on the topic by distilling all the content on the web. This invention required advances beyond Alexa conversation and conversation mode. First, web-scale neural information retrieval was needed to find relevant content. Second, there's automated summarization to provide a bite-sized answer instead of providing a set of blue links that the customer has to sift through. And third, providing in-context recommendations, just like an expert human does, for instance, in this case, a hike that you may like. Later this year, our customers will be able to have many such explorations with Alexa, and I can't wait to see that feedback. Another new capability that we are working on is to make shopping more convenient on home devices. Earlier today, Dilip talked about Style Feed, which enables popular influencers to provide inspirations to you in the Amazon app. Later this year, using the same capability will make it easy for customers to find the same inspiration for fashion, home, and beauty products on just the Echo Show screens. Further, through the convenience of voice, customers will be able to browse by simply describing what they see on the screen. For instance, in this case, you can say, Alexa, show me the white yoga pants. Customers will also be able to find similar products. For example, show me the leggings, or ask deeper product-specific questions. Do these come with pockets? All using natural language. The way this works is that through the large multimodal visual language models that I showed earlier, Alexa learns concepts such as white yoga outfit or green yoga outfit from the images and maps them to spoken words. A key hallmark of general intelligence, which today is best exhibited by humans, is the ability to reason based on short-term context available in the moment and long-term memory accumulated over years of experience. Today, Alexa exhibits reasoning when processing requests that refer to a shared world context, such as if you asked it to set a reminder for Super Bowl, Alexa not only identifies the Super Bowl date and time, but converts it into the customer's time zone and reminds the customer 10 minutes before the game so that you don't miss it. Another area we have brought reasoning to our customers is with hunches and routines. Alexa can notice you forgot to lock your front door and sends you a notification. Or if Alexa notices a customer turns off a light and turns down their thermostat at nearly the same time every day, then it can suggest a routine that can automate everything for you and saves you effort and time. Reasoning using common sense is essential in enabling natural interactions as well. In fact, it is key to the open domain conversations, such as with Alexa-priced social bots that are being built by our university teams who are competing to meet our grand challenge of 20 minutes of coherent and engaging conversations. For inducing such common sense into AI, we have collected and published the largest data set for social common sense in an interactive setting called Common Sense Dialogues. We've also invented a generative approach of what we call think before you speak for modeling common sense. In this approach, the AI learns to first model implicit common sense knowledge, as in think, by combining large language models with common sense knowledge graphs such as ConceptNet. And then, in the inference step, it uses this knowledge to generate responses that is speak. For example, if during a social conversation on Valentine's Day, a customer says, Alexa, I want to buy flowers for my wife, Alexa can leverage the world knowledge and temporal context to respond with, perhaps you should get her red roses because it has inferred a romantic relationship. Moving forward, Alexa will employ more automated reasoning to answer queries that require typically multiple inference steps. For example, if a customer asks a complex query, has Austria won more skiing medals than Norway? In this case, Alexa will leverage the mention of skiing medals along with temporal context to derive the implicit reference to Winter Olympics. Second, it will resolve skiing to the set of Winter Olympics events that involve skiing, which is non-trivial because the official names of the events may not even include the word skiing, like luge and biathlon. Third, Alexa will retrieve and aggregate medal counts for each country and finally compare results. And this is where things like explainability become very important, because you just don't want a straightforward answer of just yes. You just need to give you what exactly the number of medals that were won by Norway and how many by Austria. The way we as humans explore and learn to learn is still elusive for AIs. We don't need millions of data points, nor use massive compute such as today's AI do. We have taken the first steps to more human-like learning with Astro, our home robot. Astro, just like living beings, has the ability to fully interact with the environment and assist customers beyond what static devices can do. One of my favorite features for Astro is that it hangs around in different parts of our house, just like our pets do. To increase utility of Astro, we are working on a capability for it to learn new objects, for example, doors and windows in your house, and their states directly from the end users. Let's take a look.
Astro, this is the backyard door. Yes, the door is open. I'll go close it. Thanks, buddy.
This capability builds on our invention of teachable AI, a critical pillar of generalization, where the AI learns with self-supervision and self-exploration without requiring external human input. One thing that surprised me the most about Alexa is the companionship relationship we have with it. In this companionship role, human attributes of empathy and affect are key for building trust. These attributes have become even more important in these times of the ongoing pandemic, when so many of us have lost someone we love. While AI can't eliminate that pain of loss, it can definitely make their memories last. Let's take a look on one of the new capabilities we are working on, which enables lasting personal relationships.
Alexa, can Grandma finish reading me The Wizard of Oz?
Okay. But how about my courage? Asked the lion anxiously. You have plenty of courage, I am sure, answered Oz. All you need is confidence in yourself.
As you saw in this experience, instead of Alexa's voice reading the book, it's the kid's grandma's voice. This required invention where we had to learn to produce a high-quality voice with less than a minute of recording versus hours of recording in a studio. The way we made it happen is by framing the problem as a voice conversion task and not a speech generation task. We are unquestionably living in the golden era of AI, where our dreams and science fiction are becoming a reality. I'm optimistic that ambient intelligence enabled through advances in generalizable AI will enrich daily lives of everyone everywhere. Thank you.
Well, you knew that my costume changes would get more elaborate, or you should have known. And by the way, this is not the advanced crew escape system suit that's been out in the hallway. No, I brought this one from home. I was told to dress for the job you wanted. All right, much like yesterday, today we have an amazing lineup of Innovation Spotlight speakers for you. First up, Ariel Ekblad, who heads up the MIT Space Exploration Initiative, will speak to the importance of having a plan. One of her plans is to build extraplanetary community in low Earth orbit, and her team at MIT is working to redefine the way we design and build our low Earth orbit architecture. Think Tinker Toys in space. Then, Tom Oxley from Synchron has found an innovative way to bypass the brain's defensive systems with their one-of-a-kind device to make a brain-computer interface. This breakthrough will allow the wearer to communicate with family and friends, bank and shop, all just by thinking about it. And finally, Justin Cyrus from Lunar Outpost is going to show us how its first commercial lunar rover, which is insanely cute and bears a striking resemblance to the mouse droid from Star Wars, is getting ready to help NASA explore brand new regions of the moon. So let's get started. I'd like to bring to the stage Ariel Ekblad. Please give her a warm round of applause.
Hello, good morning, ReMars. It is delightful to be here with you this morning. I'm Ariel Ekblad. I'm the director of the MIT Space Exploration Initiative, also CEO of a newly launched startup, Aurelia Institute, and I'm here today to talk to you about the ways in which we are at the cusp of interplanetary civilization. We're at a really remarkable renaissance moment in the space industry right now. Groups like Blue Origin, sending New Shepard up to suborbital space, and Virgin Galactic are really help us profoundly democratize access to space. I want to give a shout out here to Blue Origin and Erica Wagner, if she's in the audience, because Blue Origin was our first pathway within our lab at MIT to get space payloads going, and they are really transitioning and revolutionizing how we get access to translating science in the lab to real-life space artifacts. Beyond all of the excitement about these suborbital missions and space tourism, we have an unbelievable moment happening in low Earth orbit within the next few years. For many decades now, whether it was Skylab or Mir or the International Space Station or Tiangong, there have been government-run space stations in orbit. We are about to see, within the next few years, 3 commercial space stations doing science, entertainment, industrial manufacturing, begin to proliferate and profoundly change how we think about access and participation for everyday citizens in this beautiful near-Earth cocoon that we call low Earth orbit. Beyond low Earth orbit, we're already reaching out further into the near neighborhood of our solar system. Some of you may know the Artemis program at NASA is sending the first human crew back to the surface of the moon in over 50 years this decade. Also particularly meaningful for some of us is that we will send the first woman to the surface of the moon, and that the work that we do to establish a sustainable lunar settlement this time as we like to say at MIT, we're going to the moon to stay, will also help us as a gateway to Mars, this Moon to Mars program. We're seeing plans already, credible plans, for human Mars missions in the 2030s. And what this reminds us is that this idea of an expansive human presence in space is no longer science fiction, it is at our doorstep. And speaking of science fiction, at my lab at MIT, we are working on building and prototyping and testing and deploying the artifacts of our sci-fi space future, because we are here. So while space entrepreneurs and ESA and NASA work on the rockets to get us there, wherever there may be, Mars, Moon, or beyond, we are working on the human lived experience of space. What are the tools, the products, the experiences, the technologies that you would want to see for a life where you actually envision yourself in a floating microgravity space habitat? We train the space generation, the next generation of explorers, of tourists, of day-to-day workers who are going to be able to actually participate in this future. My lab at MIT supports over 50 graduate students, staff, and faculty, and we start everybody on an annual parabolic flight. I wonder if anybody in the audience has done a parabolic flight before or knows what a zero-G flight is. You can raise your hands if you do. They are affectionately known as the Vomit Comet because they fly parabolic arcs in the sky, like a roller coaster in the sky, and are able to simulate weightlessness. This is how we start our team in the process of not just being a design house or a speculative R&D group, but actually having a launch pipeline for how we get our work tested out in the field in microgravity and in space. So from zero-G flights, here you can see an image of that plane doing that characteristic parabolic maneuver, we move to suborbital platforms like New Shepard with Blue Origin. We've just completed multiple International Space Station missions over the last couple of years and have 2 more planned in the coming months. And I'd love to announce here today on this stage, we have our sights set on the moon. We have a little bit of a fun inside baseball reference for those of you who are here today and going to see Justin Cyrus's talk. We at MIT just signed MIT's first ever commercial lunar contract to go to the moon. This means we didn't wait in a grant pipeline for 5 or 10 years to ask NASA to take us along on a launch. We went to Lunar Outpost, you're going to hear from Justin Cyrus shortly about the MAP rover, and said, we want to buy payload space. We want to go now. We want to go quick. And so hopefully, as soon as a few months from now, maybe next year, we'll be flying a swarm robot inspired by Neil Stephenson's 7 Eves and a depth field camera that's going to take the first ever footage of this really profound area of the lunar South Pole and take that depth field imagery, pipe it into VR and AR training for that first human return crew, that Artemis 3 crew going to the surface of the moon in the future. So we're so excited to be able to actually share this fun fact with all of you, especially since you'll be hearing from Justin a little bit later today. This is the team, a representation of the team. As I mentioned before, it's a large undertaking. We have over 40 research projects in our portfolio at any one time, and it takes a team not just of scientists and engineers like myself, but also designers and artists and ethicists, and a really rich envisioning of the future for life in space. We work on everything from zero-gravity 3D printing and additive manufacturing to space fashion, to self-assembly and structures that you'll hear a little bit more about from me later. And part of our goal with this breadth of projects is to represent the beauty of interdisciplinarity, which is something that we are really cherish at the MIT Media Lab, where we do have biologists sitting right next to, in their wet labs, AI scientists, roboticists, creative architects. And one of the things that we hope to do with the Space Exploration Initiative at MIT in particular is to say, we have this amazing blank slate of space, living life in space. And we have this opportunity to design new cultural artifacts for that environment. As an example, instead of always importing from Earth musical instruments that we've always played here, what would it look like to design a musical instrument that could only be played in microgravity, that has a unique way of experiencing and delighting humans in that environment? So these are the different types of projects that we work on with an amazing team at MIT, and you can see the breadth of some of the research here. I'm now going to tell you a little bit more about my favorite pet project, my PhD research, which I completed a few years ago. Our goal, beyond just these component technologies and the artifacts that you might experience within a space habitat, is to think even grander. What are the space habitats themselves that are worthy of a life worth lived in space? How can we begin to design robotics technology that is self-assembling? You'll see a video in a few moments of how this technology that I call tesserae works. The idea is that we can stack tiles flat in a rocket, pentagons and hexagons. They are released into microgravity to elegantly float and self-assemble and form a buckyball. This is just one idea. Once you've been able to make the geometry modular like this, you can imagine many different space structures being able to be built that are much larger than any particular rocket payload fairing. This is what we think will help us scale to becoming a truly spacefaring civilization. The inspiration for thinking differently about this space architecture itself as infrastructure was looking at the examples of space architecture that we have thus far, amazing feats of engineering, but pretty limited to aluminum tin cans, to pressure cylinders, to axial geometries. What would it look like to think about a totally different model, a different paradigm for creating large-scale structures in orbit? And I think it needs to be robotic, it needs to be autonomous, and instead of being put together like this, as stunning as this image is, it's incredibly risky. It's an astronaut risking their life in a spacesuit, pretending like we're going to build and construct buildings in the vacuum like we build on Earth, where we have a construction crew outside working on a building. There's so much potential to learn and think about different ways that we could actually assemble hardware. One of the sources of inspiration that we draw from is nature. What you're seeing in this image is Phyllotaxis, and what we like about this is that it's an example of a grown structure. Can we grow space architecture in the future, incrementally, piece by piece, self-assembling? Each unit in this image is a little bit different in size, but predictable in overall geometry, and allows for a certain growth mechanism to really expand and scale. and we're taking some of these biomimetic principles into the work of building Tesserae. I'm now going to show you a video and just talk over it lightly as it goes. This is an artist's conception, I will say as a scientist, a far future conception. We are working on the prototype hardware that you'll see in a minute, of just how Tesserae, a self-assembling space structure, might work. So here we see a rocket leaving Earth, rocket payload fairing. As this rocket makes its journey to whatever orbital environment we're headed to, it could be around the moon, in this case it's around Mars, you'll see that the rocket payload fairing begins to open. And what's inside of it is essentially a glorified Pez dispenser. It's a way of stacking and releasing these pentagon and hexagon tiles one by one at a time. Here you can see that idea of the stack. On the edge of each of these tiles, we've designed custom, very powerful electro-permanent magnets. These are magnets that are always attractive, but you can pulse current through them to turn them off. What this means is as the tiles are released to float in a microgravity environment, they want to find each other. They want to dock to their nearest neighbor, and if they dock incorrectly, the sensing and the robotics and the autonomy built into this system can detect that and pulse them off and give them a chance to reassemble. This stochastic-like process is again harkening back to processes in nature for how things self-assemble. And what you see here is an idea of the module coming together, that buckyball forming, and the hope that in the future, once we build one module, we would actually be able to dock multiple of these different modules together and form a more complicated space station. Now that's the artist's vision. This is the prototype hardware. We're now actually on version 4. These are the 3 that I can show you. That's the code, the platform, the hardware, the sensors, the electronics that are being matured over the course of multiple different flight missions. So 2 parabolic flights, a New Shepard Blue Origin flight, and 2 International Space Station missions. And to bridge from this miniature hardware, which is about the size of a dinner plate or the size of my palm, we also do rigorous physics modeling to simulate at-scale human-sized tiles and how they would respond in this environment if we were actually trying to assemble this ball in an orbital environment with the Earth's magnetic field and all of these other realistic factors in orbit. Here's a shot of the Tesserae tiles on the historic Axiom 1 mission. We had an amazing opportunity, again an example of how the space industry is changing, on this fully private mission to the International Space Station to test out the Tesserae tiles and did see a stable dome form, which was absolutely fantastic for us in the progression of the research. And our hope with this work is to one day be able to build grand monuments like this. This was meant to be Newton's cenotaph, conceived of in the 1800s, 150-meter span dome, would have been impossible to build because gravity is hard, gravity sucks to build against. But if we could actually begin to think about grand, inspiring space cathedrals, or microgravity concert halls, or expansive space laboratories in orbit, this is the kind of vision that we think we can enable. And this brings us to the anthropocosmos. So with all of these amazing opportunities for the future of life in space and building space architecture, we also have a really significant responsibility as stewards of the space commons. And this is harkening back to the term Anthropocene, our understanding, our growing understanding of the role that humans have had, for better and for worse, on our planet. We ought to be really thoughtful early on about the ethics and the ways in which we will act in this near neighborhood of our solar system as we as humanity go out into the cosmos. And in the spirit of this reflection, we released a book with MIT Press last year on the MIT side that is essentially a catalog of those 40-plus projects that I mentioned, but also a statement of our principles and our ethics around how we should be thoughtful, inclusive, and equitable about the future of life in space. What I realized we really needed after this, building beyond the MIT lab ecosystem, is a real-life Starfleet Academy. Any of you Star Trek fans out there will know this reference. It is where the space cadets always went to learn to become Captain Jean-Luc Picard, a space captain, a space doctor, a space lawyer. But it was also where the technology of the Enterprise was built. And I think we have a real opportunity with the new organization that I've just founded to bring a concept like this to life. So this is a stealth organization. We just went public this spring. The name Aurelia is an Old English word for chrysalis, and the meaning behind that logo is to call out the fact that we, humanity, are at the cusp of our next metamorphosis into a spacefaring species. Aurelia will be a profoundly humanist approach to scaling access to space, and will work on 3 different pillars. The first is advanced technology R&D for space habitats. The second is education and outreach in the spirit of Starfleet Academy, doing zero-gravity flights for a much broader population beyond MIT, getting ways and courses and educational offerings out to the public. And the third will be a policy think tank so that we are aware of the impact that we might have as participants in the Space Commons before we get there and are thinking thoughtfully about our impact. We're excited to take the same iterative approach that we've done at MIT to structures like this, artificial gravity, self-assembling structures, origami, inflatables, and not just do the artist's render and say this was fun, this was an architectural envisioning project, but actually begin the technical roadmap work so that after this near future that we're already seeing in low Earth orbit, where the Axiom, Orbital Reef, NanoRack stations will be there, maybe technologies like these, grand, inspiring space architecture, really will be ready to be that next generation. We're spinning out of the MIT Space Exploration Initiative with this work. And what we'd like to say is follow along. For those of you who might want to collaborate with us, this is the Aurelia team. And fundamentally, we're seeing so many different propulsion pioneers and space entrepreneurs build us the road to space. It's time to take that road. We think it's time to build space architecture that will make it a life worth living in space. Thank you so much.
Please welcome the Chief Executive Officer at Synchron Incorporated, Tom Oxley.
Good morning. A little bit of a change of pace from space to brains, although I don't see a B in the Mars acronym, but maybe that'll change soon. I'm Tom Oxley, I'm the CEO of Synchron, and we have built a brain-computer interface. So a few months ago, I surrendered the password to my Twitter account, and I let a person with paralysis tweet out their thoughts. But I mean that literally. You see, Philip O'Keefe can't use his fingers to type like you or I, but thanks to a tiny brain implant, he was able to send the following tweets. Hello world, short tweet, monumental progress. No need for keystrokes or voices. I created this tweet just by thinking it. And then finally, my hope is that I'm paving the way for people to tweet through thoughts, Phil. Now I know what you're thinking. There are people out there who should not be allowed to tweet directly from their brain. I agree. But for people with paralysis and disability, well, this technology can be completely life-changing. I'm a neurologist and neuroscientist. I've been passionate about the brain since the age of 13, predominantly with what I think personally is the most profound question facing humanity: how does the brain manifest consciousness? But it was an experience I had as a neurology resident 10 years ago that really got me thinking deeply about how this technology could be so powerful and useful for people. I looked after a 40-year-old man. It was one of my first rotations in the stroke team. And a 40-year-old man came in, and he'd had a massive stroke. It was actually a tiny part of his brain. He was a father of 3 in the prime of his life. But this tiny little part of the brain called the pons, the little dark region there, that carries all the information exiting your brain. And that got damaged from a blood clot. He couldn't move any part of his body. He could hear, he could see, he could think, he could feel, but he couldn't move and he couldn't talk. He was locked in. And we sat with him and we talked about what this meant, and he was communicating yes and no, left and right with his eyes. And he told us that, well, if there's no cure, I don't want to live like this. And so we supported his wish to be taken off life support. And so I've been thinking ever since then, is there really no other way? Connection is a fundamental human need. And so many of our patients lose the ability to talk, to connect. For years and for decades, they're stuck inside their own bodies. This was a moment with one of our patients reconnecting, and I'm going to come back to this image later on, but this is the power of this technology and the ability to reconnect people back to their world. So for people who have lost the ability to move their bodies, who have paralysis, do you know what the #1 request is? Imagine that you lost your ability to engage in the digital world. What would it be? Well, it's text messaging. Text messaging. And after the last 20 years, you guys have built these unthinkably powerful systems. We can do video conferencing, we can shop online, we can order food, we can do banking, we can do trading, we can manage our finances, we can seek healthcare, all without really moving. But only if you can access the web. So we talk about Web3, the metaverse, democratized access for all, but for 100 million people who can't use their hands, well, they don't have access to that web. So when technology is now needed to fulfill basic human needs, that's not a luxury. That's a fundamental human right. And that's what I think brain-computer interface technology is about. Last year, we became the first company to receive FDA approval to conduct a clinical trial in the US, heading towards FDA approval of the first commercial brain-computer interface company. I'm going to talk to you guys what that looks like, how we got here, what we did differently, and how BCIs are going to fundamentally change the way we connect with technology. Okay, so in simplest terms, BCIs solve the problem of getting information out of the brain to an external device. Now, the way we normally do that is by thinking what you want to do and then getting the information out using the muscles. Muscles in your mouth, muscles in your hand, muscles in your fingers. Because right now, the only way to communicate anything is through your muscles. So how do you get information out of the brain without speaking or writing? Well, telepathy, obviously. I'm joking. Sort of. Okay, first let's consider how the brain works. Actually, how thinking works. And I want to take you to what I found to be an incredibly romantic place where I first proposed to my wife in the Smoky Mountains. Fireflies synchronize their flashing. And it was a mystery for centuries for scientists with how they did that. Ended up being two simple things. One, a firefly has a metronome, which is a beating cadence. And two, the fireflies around one another change, speed up or slow down their beating to get in sync. And they can give the appearance of one enormous organism. Well, that's how the brain works. Individual neurons beat at a certain frequency, and the speed of that frequency is influenced by the speed of neurons immediately around that neuron. So they behave in these groups. And as they beat at a certain frequency, doing a certain function, then that pathway gets laid down stronger and stronger. That's the basis of neuroplasticity, or learning. So it's also called neural oscillations. So the concept, that's the basis of thinking. So the concept for BCI is, how do we get that information directly out of the brain in real time to then convert units of brain activity into a function that can control external devices? That's exactly what a BCI does. Easy, right? Not exactly. So this is the Utah array. This is what got me into the field when I first read about this in 2006. Fundamental, basic breakthrough research conducted using this bed of nails electrode. Incredible work. For 15, 20 years, we've been using this in a very low number, handful of patients, proving this is possible. The challenge is that this requires open brain surgery. And at a fundamental level, we'll get to brain surgery in a minute, but the brain doesn't really like having needles stuck into it. Now, it seems like a glib comment, but it's not necessarily the case in the rest of the body. Look at tattoos. They can sit there forever. There's no immune response. The brain's different. It's very sensitive, and it will continue to keep pushing things out. Open brain surgery, well, that's also a pretty big deal. It's expensive, takes a long time. There aren't many people in the country that can do it, especially the type of brain surgery where you get to particular regions within the brain. It's called functional neurosurgery. About 150 of them in the US. So the question that I've been obsessed with, is there any other way to get into the brain? The answer is yes. We found another way, but we didn't actually find it. It's been there for a long time. This is what it looks like. These are the blood vessels, a naturally occurring road infrastructure that get to every corner of the brain. At the very top there is the superior sagittal sinus, happens to be the largest blood vessel in the brain, right next to the area of the brain that we're interested in called the motor cortex, which is how you control your muscles. Now, the thing is, we actually already know how to get through these blood vessels. We've been doing it for 40 years. If anyone's had a heart attack, there's a decent chance that you've had a stent. So you had a blocked blood vessel, a balloon was put up, stretched open the blood vessel, and then a scaffold was left in place to keep the blood vessel open with blood flowing through it. That's called a stent. I'm sure all of you know someone who's had a stent. So the technology is being developed over the last 40 years to deliver technology into blood vessels in the heart, and we're just starting to figure that out for the brain. The beauty of this is that you achieve that non-immune reaction situation because the blood vessels behave like the skin, and if you leave things on the inside, they get incorporated, and it just behaves like a tattoo. It can stay there forever. So, the breakthrough, one more point. Millions of these stents are placed every year. Millions of cardiac pacemakers are placed every year, not in the operating room and not by a very low number of physicians, by a large number of physicians in what's called the cath lab. That's where you go to get stents put in, and they're at any neighborhood hospital. So, the problem we had to solve was, how can we get electronics onto a stent, deliverable in a scalable medical outpatient situation, and then deliver that into the brain? And so this is what we built. We built an electronics platform onto a stent that achieved the self-expanding properties of the stent and was able to get safely into the brain. So it's connected to a stent. It's in the area of the brain that we want. It's connected to a lead. The lead brings the information out of the brain through a naturally occurring hole in the skull. We're not putting any new holes in the skull. And we're doing it all in a way that's accessible for millions of people. And so here it is. Here it is inside our first patient, Graham, who's very kindly offered to let you see what it looks like inside his brain. And we've just put a little blue highlight over the area so you can see where the lead is coming out of the brain. This was in 2019. It was one of the most incredible moments of my life seeing this image. There's a big build-up to the surgery, to the procedure. This came up on the screen. The device was in. First time in history, there was an electronics inside a brain, inside a blood vessel. And then a couple of hours later, he woke up, asked if he was still alive. He was. And then we got him home. We got him home a couple of days later, and we started working with him and conducting some incredible work over the next couple of years. So here's the system. On the left, you see the Stentrode, which is a stent electrode array connected to a lead. That goes inside the blood vessel, comes out of the jugular vein. That goes into a device that sits under the skin in the chest that has a battery and has a telecommunication protocol using Bluetooth that sends the information out of the body wirelessly. That gets picked up by the white device there on the external side, which is a mobile device, does not have a screen. It does the algorithm processing and then shoots that out to any connected device through Bluetooth as well. This is what it looks like. So the electrodes are the circles on the top of the brain there. Now, the concept here is that when you try to move muscles in your body, we can detect the change in brain signal that occurs when you try to move. And so this is a very simple demonstration of a spectrogram which shows what it looks like in the blue before you're trying to move and in the red after you're trying to move. So we then use our engineering to decode specific movements inside the brain and then turn those into outputs. So the first one that we started with was the foot, because we're right near the foot region in the brain. So we'll ask the patient to try and tap down their foot. They won't do it because they're paralyzed, but we've been able to decode those specific movements. And then we start building out a dictionary, building out a repertoire of different types of movements. Hand waving, maybe finger tapping. We're starting to calibrate multiple different movements. Now these become the building blocks for every single control mechanism that you need to control digital everyday devices. Now we're just at the beginning. This is not an incredibly complicated control mechanism. We're just trying to get a simple, robust functionality to do the basic things. up, down, left, right, menu, back, the things that let you fundamentally control basic systems that give you power, get back to the powerful platforms. So once we've got one of these movements, we'll then go into a game situation and ask the patient to start practicing using that particular type of switch so that we can get the system getting better and better at that switch. This function allows patients to then use their smartphones, eventually wheelchairs, advanced robotics. But bringing it all together in action, we started with a PC, and here we are with two of our patients. So this is Philip. There is brain signals on the system there. That's streaming out of the body via Bluetooth, and then we've built in functionality to control keyboard and mouse control. We've got different mechanisms given the level of disability for the patients and what system they're using at home to engage with. So Philip said to us once, it's like learning to ride a bike. It takes practice. Now when you think about it, it becomes natural. Now I can email, bank, shop, and message the world via Twitter. At the end, we finally got them onto a group chat on WhatsApp, and we're finding that the messaging was the most powerful thing for these patients. So we had two of our patients messaging each other, and I was on there as well. The term Renaissance was used in the previous presentation by Ariel in regards to space, and I think we're in the same situation with brain technology now. When I started neurology training as a resident, it was the backwater. It was the laughing stock from all the other physicians and not high up on the sexy list of what area of medicine you're going to chase. And the reason for that is that you can't fix things in neurology traditionally. You can't fix broken neurons, but brain-computer interface is now bypassing this and creating a direct connection into the brain. I think we're going to see an incredible progress in a range of different conditions now, not just paralysis, epilepsy, depression, stroke, addiction, pain, sleep, headache. We're just getting started. So over the next 20 or 30 years, what's BCI, where's it going? There's been a lot of talk about what it might mean for the broader population, but what I think we're going to see is that BCI becomes a LASIK kind of situation. An elective procedure, takes a couple of hours, makes your brain work a little bit better, you engage with the digital world better than you did before, and you're not coming in because you've got profound injury. Maybe you've got a minor injury, but it stopped your ability to engage with your technology interactions. And who knows where we're going to be in 20 years. So it could be that a small drop-off in your ability to connect technologically could have a huge impact on your ability to behave in the world, exist in the world. And so that's what I think this technology is going to do. Not take us to some cyborg Black Mirror situation, just to bring us back up to where we'd like to be. So just to finish with, this was Graham and Nancy. The moment when he first was able to put his first sentence on the screen, the next hour we put him onto WhatsApp. Up to this point, he had ALS. Nancy was having to try and interpret what he was saying. He couldn't speak, he can't move, he couldn't type. We got him back typing, we got him back onto Microsoft Windows 10, and then he was onto WhatsApp, and all of a sudden she could leave the house again. If you remember that moment when you first got your phone and you first started texting, or maybe the first time you got your car and the world opened up, well, that's what we're trying to offer for the patients whose world has closed down. And there's a lot of people in the world like that. This technology is about the return of autonomy, the return of independence, but mostly it's about the return of dignity. Thank you very much.
Please welcome the Chief Executive Officer at Lunar Outpost, Justin Cyrus.
Hi, my name's Justin Cyrus, and I'm the CEO of Lunar Outpost. And this, coming on stage, is our mobile autonomous prospecting platform, MAP, that's headed to the moon within a year. Now, on video behind me, you'll see a few of our first missions that are going to start this year and go into 2025. But before we dive into the missions or how robots are unlocking space, let's talk a little bit more about why Lunar Outpost was founded. So I was fortunate enough to grow up next to NASA Johnson Space Center with some of the top scientists and engineers on the planet. And unfortunately, some of them got frustrated by the lack of progress we were making towards making space sustainable and pushing beyond Earth's boundaries. So that told me very early on, we need to find a reason to go into space and commercialize if we truly are going to successfully push beyond the bounds of Earth. And on screen behind me, you'll see our Hippo, our 1,000-kilogram class robotic system that's purpose-built to do just that. And one of the first commercial applications of robots in space will be resources. There are two things that space has an infinite amount of. The first is power, and the second is resources. And if we can find a way to access either one of those two things, we can fundamentally change the way that we operate as humanity. And on screen behind me, you'll see Hippo utilizing its rocket mining technology to extract materials from meters below the lunar surface, process them, and then deliver them out of that permanently shadowed region. Now, there are many other commercial use cases as well. And one of the most exciting that I'm really looking forward to being a part of is tourism. Commercial tourism, having folks go and stay on the moon just like a vacation if you come to Las Vegas or you head out to LA. And with that commercial tourism, they will be able to utilize the infrastructure that NASA is putting in place and these outposts that are being built and maintained by robotic systems just like MAP. So one of the benefits that we have now that we've never really had before is strong support, not only from the investment community, awesome investors are getting into this space, but also from government agencies such as NASA, ESA, Luxembourg Space Agency, and others. And that strong public-private partnerships start enabling new business cases that weren't possible in the past. And so here in a second, you'll see the NASA administrator handing me the first check in human history for space resources. And what this does is set a legal and procedural framework for our company and companies like ours for generations to come to go out and commercialize space. So what we do at Lunar Outpost is create fully autonomous robots and software for conquering extreme environments. And of course, true to our namesake, one of those environments is the lunar surface. And all of this is building towards our vision to end scarcity here on Earth, to address all the material shortages that we have, and truly enable a more fair and equitable economy and ecosystem. So accessing those infinite resources of space. Now, here's where we're at today. We have already deployed thousands of products here on Earth and collected over 35 billion data points at well over 99% uptime. And this not only shows that we can commercialize a product and scale it, but it's allowed us to put a cloud architecture in place through AWS that we can now leverage for our data processing on the moon. We're currently operating on Mars as part of the MOXIE program that's led by Dr. Forrest Mayan, who's sitting in this crowd today. And that's a project led by MIT and NASA that's taking CO2 out of the Martian atmosphere and turning it into oxygen through a reverse fuel cell process running at about 800 degrees Celsius. And then, of course, we have multiple contracted missions to the lunar surface. The first of which is fully commercial and will be the first rover at the lunar South Pole in human history. So this location is not only exciting because of the resource implications that we talked about earlier, but it's also pretty exciting because that's where astronauts are headed in 2025. So think of this a bit as a scouting mission. But as you heard in Ariel's talk, a few minutes ago, this is a commercial mission. We actually only have literally $1 from NASA on this entire mission. The rest of our customers are strong commercial industry partners and research institutes that are leading the way towards making space more sustainable. And a few of those payloads are from MIT. And of course, we have Nokia's LTE high bandwidth communication technology that we'll be deploying on the lunar surface. Now, here's where we're at today. I love showing pictures to show you guys it's real. This truly is going to be flying within 12 months. We have done vibration and shock testing to make sure we can survive the launch and landing environments, which can be quite harsh. We have done TVAC testing and testing at the Lunar Testbed Facility to ensure our robots can operate not only for a few days, but years at a time on the lunar surface, which starts enabling those new use cases. And as we develop this technology, we're also lining up future missions. So our second mission is a fully funded NASA mission that's headed to Reiner Gamma, a magnetic anomaly on the lunar surface that has puzzled scientists for hundreds of years. And Lunar Outpost, along with Johns Hopkins Applied Physics Laboratory, our job is to go figure out why is that anomaly there, so we can learn more about the formation of the moon and our solar system. Now, that's really just the beginning. Those are our two first missions, but there are dozens of landers headed to the moon this decade, starting with Intuitive Machines' IM-1 mission this December. And what this allows for the first time is continuous, reliable access to the surface of the moon. And with that reliable access, you can start building business cases off of that infrastructure. And by the time we get to 2025, we will have heavy lift launch and landing capabilities where we can land and return tons of cargo and humans to and from the lunar surface. So this is truly a revolutionary moment in the space economy. So what is Lunar Outpost doing about it? This is our game plan. This is what our robotics are purpose-built for. We're starting off with planetary mobility, spacecraft as a service, if you will. So taking government and commercial payloads to the lunar surface. So similar to how launch provides people access to different points in space, Lunar Outpost provides folks access to different points on planetary bodies. It's as simple as that. We're building out towards the infrastructure in cislunar space. So a lot of folks utilizing robotic systems are going to be creating this infrastructure for the first time and maintaining it as well. And then we are working towards utilizing that infrastructure for our long-term goal of the utilization of space resources. So let's dive in a little bit more. Planetary mobility. So this is the Mobile Autonomous Prospecting Platform. This is very close to what we're actually going to be sending up next year. It's only about a 10-kilogram class platform, size of a small dog if it's hard to tell from the audience how big it is. But compare that to the current state of the art. You might be wondering, why are we going for smaller rovers? What is our goal? What are we trying to accomplish? Currently, Mars Perseverance rover, awesome, amazing feat of technological and science engineering. However, it costs $3 billion. If we're truly going to make space sustainable, we need to bring that cost down by orders of magnitude. And then look at NASA's Viper rover, going to the moon next year or in a couple of years, and it costs around $500 million. It's going to last for about 100 Earth days. But these are purpose-built science and exploration robotic systems. Lunar Outpost has created a line of robotic systems that are commercial to drive that cost down and to truly make space sustainable, starting with MAP. And as we build our way up, you'll see a few of these robots throughout the presentation. We have HL MAP, a 300-kilogram class system, and working our way up to Hippo, that 1,000-kilogram class robot. And of course, we cannot forget astronaut mobility. We'll find out. I'm kind of hoping I have a self-driving car here soon. I've been wanting one for a while, but I think astronauts might have it sooner than we have it here on Earth. So the next generation of lunar mobility is going to be led by Lunar Outpost and our partners, Northrop Grumman, Intuitive Machines, AVL, and Michelin, to provide these astronauts access to these different regions on the lunar surface. Now let's talk a little bit just why you can't take an Earth robot, yeet it up on a SpaceX Falcon 9 and have it work in space. It's a very harsh environment. You not only have high radiation that will fry most commercial electronics, but you also have a very dynamic environment, going from negative 200 degrees Celsius to plus 200 degrees Celsius over the course of one lunar day-night cycle. And then you have other factors, including electrostatic regolith, that stick to the solar panels and are hard to mitigate. That combined with limited supporting infrastructure, no GPS, and other technologies, it makes it a very difficult prospect to operate on these planetary bodies. So Lunar Outpost is doing significant testing out at relevant environments. This is actually the Great Sand Dunes. I love this picture. If you've never been, awesome park in southern Colorado, very beautiful, pristine. NASA does some robotics competitions out there, and with the right permits, you can go test your robots out there as well. And what we test for is the operations. You know, those 14-day operational timeframes to really start ironing out all the bugs before we get on the lunar surface. So combine this with the thermal vacuum in the Lunar Testbed Facility, we're confident that our robotics systems will be reliable on the lunar surface. And what that enables is robots unlocking space. Robots that are going to start building and maintaining large-scale infrastructure on the moon. And this is actually a picture from NASA from decades ago. And honestly, they got it pretty darn close of what these outposts are going to look like. You have everything from the habitats to life support systems to the power communications, launch and landing pads, and roads. And Lunar Outpost has a contract with NASA actually to make launch and landing pads for heavy lift landers, which we're quite excited about. But robotic systems will create this infrastructure and maintain it over time so we can properly leverage our astronauts' skill sets on these other planetary bodies and make the most of their time there. Now, I do want to leave you with a little bit of food for thought. Space resources. I told you we can go out and extract them. I told you there's an infinite amount of space resources, but what resources are actually available on the moon specifically? One of the first that people are going to go access is water ice, hydrogen and oxygen, but it's extremely valuable in the cislunar economy, not only for astronauts, for consumption, for life support systems, but also for refueling in space and to utilize as a rocket fuel to get transports back off the moon. And there are other more exciting resources as well that are extremely rare and scarce here on Earth. And one of my favorites is helium-3, a rare isotope that when combined with fusion energy becomes the most valuable material on Earth. It is currently trading for about $16,000 per gram. That's more than gold, silver, platinum group metals, or palladium. And this is plentiful on the lunar surface within the first few centimeters because it has been deposited by solar winds over billions of years. And that's just one resource. There are infinite types of resources that we can access, whether it's for manufacturing on the moon, manufacturing in cislunar space, high-value platinum group metals that we want to bring back here to Earth. That's really just the tip of the iceberg. So how are we going to get there? These are our first few steps as a company. We have our first mission going to the lunar South Pole within a year. We have our second mission headed to Reiner Gamma, a magnetic anomaly that's been puzzling scientists for generations. And as a part of those first two missions, our goal is to prove that it's possible, to leverage the transportation and other infrastructure that's being put in place so we can start building towards our long-term vision of accessing the infinite resources of space. So thank you very much for taking the time to listen to this talk. We are growing quite quickly, and we would love to see a lot of your resumes. I'll just, no shame on that one. Honestly, please apply, come visit us at the booth. There's a lot of folks out in the expo. Thank you.
I could just stay up here for the whole time it takes to get off. There you go. We have just finished 2 days down at Amazon Remars, and we aren't done yet. You won't want to miss tomorrow's presentations as we close out this year's event. And you definitely want to join us at happy hour at 6 p.m. tonight in the Tech Showcase, which promises to be full of some surprises. That's a wrap for today, folks. See you all tomorrow morning at 9 a.m. Have a good night.